Hi, my name is Dhaha Adnan. I'm 14 years old from grade 10A in Dubai National School. And today I'll be talking about a topic in physics, which is waves. First, let me introduce you to what waves are. A wave can be thought of as a disturbance that travels through space and time, accompanied by a transfer of energy. It transfers energy from place to place without transferring matter, which means that the particles of matter in the medium return to their fixed position. And to give an example of that is when we see a move through an ocean, yet the water always returns to its resting position. Waves are an extremely important part of physics. An understanding of waves is essential to understand a wide range of physical phenomena, including light and the wave properties of matter, including electrons and atoms. It's also a necessary part of the workings of our planet. The motions they create perform a vital role in transporting energy around the globe. Now, some waves transfer energy through the vibration of particles, but the particles themselves move in a perpendicular style to the horizontal movement of the wave. Energy is transformed between potential and kinetic energy as the particles go from rest to movement and back to rest. Now, if we want to study waves, we should know about its wavelength. The wavelength of a wave describes how long the wave is. The distance from the crest, the top part of one wave, to the crest of the next wave is the wavelength. And we can also measure it from the trough, the bottom part of one wave, to the trough of the next wave, and get the same value for the wavelength. And another thing that is important to know about waves is its frequency. Frequency is a measurement of how often a wave occurs in a measured amount of time. Only moving waves which vary their positions with respect to time possesses frequency. And frequency is one way to define how fast a wave moves. Now, there's a relationship between frequency and wavelength. Frequency and wavelength are inversely proportional to each other, which means that the wave with the greatest frequency has the shortest wavelength. And twice the frequency means one half of the wavelength. Now I'm going to talk about the types of waves. We have three types of waves: mechanical waves, electromagnetic waves, and matter waves. First of all, mechanical waves. A mechanical wave is a wave that is not capable of sending its energy through a vacuum. This means that they require a medium in order to transport their energy from one location to another. And a sound wave is an example of a mechanical wave. Sound waves are a type of energy that is released when an object vibrates. When an object vibrates, it causes movement in the surrounding air molecules. These molecules bump into the molecules close to them, causing them to vibrate as well. Those waves travel from their source through a medium like air or water and then come into contact with our eardrums. Our brain translates the pressure waves into words or signals we can understand, or the waves will keep on going until the molecules run out of energy. So for that reason, sound is not heard in space because it's a vacuum and there isn't any particles for the sound to travel through. Electromagnetic waves. Electromagnetic waves are waves that are created as a result of vibrations between an electric field and a magnetic field. An example of that is microwaves. A microwave is simply a wave of electrical and magnetic energy moving together through space. Microwaves have a range of applications, including communication, radar, and perhaps best known by most people, cooking. And now, finally, matter waves. Matter waves are a set of waves that represent the behavior of an elementary particle or some atom and molecules under certain conditions. A very simple example of a matter wave is water waves. Water waves are a swell on the surface of a body of water, normally having a forward motion distinct from the motion of the particles that compose it. And that's the end of today's topic. Thank you for listening.